Hello everyone, welcome to another edition of our online teaching. In this class we will be looking at the solution to the test that was given to you this week, and I have a plain sheet of paper somewhere here and I will be solving on them. Just make sure you go through and you will understand the class. Thank you. Now the first question, as you can see, which of the following fundamental quantities can be used in determining the density of a regular shape? Determining the density of a regular shape, you will need the words. Let's go by the way of the formula. The formula for calculating density is mass over volume. And of course, if it is actually a regular shape, of course you have the volume of different regular shapes. So yeah, I'm going by volume, let's say length times breadth times height, so something like that. And if you check all what you have here, you see that the best option here will be option B. So number one, I'll go for B. Now number two, the volume of a substance is a measure of the watts. Of course, that will be the space it occupies. That will be number two is D. Number three, an object of mass, an object of weight 0.3 Newton in air and 0.5 Newton in water. Determine the relative density. Now in this case, using this formula will make it much more easier for you to get. So weight in air over the apparent weight in water. So apparent weight in water will be the weight in air minus the weight in water. And if you check this will be 0.3 all divided by 0.3 minus 0.15. And of course this is the weight in water, so this gives you 0.3 over 0.15. And if you do that very well, the answer should be 2. So let's go by the option. So number 3, so let me just tick it. We have this for this, and this for this. So quick one. So number 4, the motion of an ant looking for food. Of course that is random, so you have that to be random. So and the next thing now is, let's go to the next page. In this next page we have which of the following situation is not a result of application of force. And if you check that very well, the answer is not motion, is not change, is not a body falling freely under gravity. Motion of a body with constant speed. Of course, when a body is moving with constant speed, the acceleration is 0, and when acceleration is 0, force is 0. So that will be 5. Then number 6, which of the following liquid will be the most viscous? Of course, the answer should be palm oil. Of course, yes, palm oil. Which of the following statements is or are correct about a body describing uniform circular motion? So when you look at this, a body describing a uniform circular motion, the velocity changes. Yes, that is correct. So the body undergoes acceleration. The acceleration is always perpendicular to the velocity. That's correct. The velocity is tangential to the path of motion. That is also very, very correct. So this will be the diagram here. Acceleration will always act towards the point of, towards the midpoint. So in this case, we'll go for G. 1, 2, 3, they are all correct. The speedometer of a moving car gives the origin of a car's check this, not average speed. The answer is instantaneous speed, and that will be 8, option C. A body moves with starting from rest. When a body starts from rest, what happens to the initial speed? The initial speed is 0. So here, if you check very well, we have distance, we have time. So we are asked to calculate the acceleration. So in that case, the equation of motion relating distance, time with acceleration will be half AT squared. And of course, this is 0. So you have this, which is 1000 equals to half times A times T. If you check T very well, T is 10 seconds. So that will be 10 times 10. And if you do that very well, 2 of these will cancel this. So acceleration here will be 20. So if you check that, let's see, yes, that will be D. Option is D. Now number 10. Number 10. So let's see number 10. The distance covered by a body in a free fall is proportional to, in this case, we will be using H equal to the distance covered by a body in a free fall is proportional to, here is going to be proportional to the square of, yes, that will be the square of the time of flight, because your g is constant and your u of course is 0 because it's dropping. So that will be C for this. And let's check again number 11. In number 11, a uniform meter rule. Okay, in this case, this is how we go about this kind of question. So whenever you are given a meter rule and you are asked to find the mass of the meter rule, do not forget a meter rule is a uniform solid, a rigid body, a regular body. So in that case, the weight will be at its center. So the mass will be at its center. And if it is truly a uniform meter rule, is going to have a total length of 100 cm. So if that is the case, weight of the body or the mass of the body will be at the center. That's 50. So let's go on. The uniform meter rule is balanced on a fulcrum at where 35 cm. You don't expect 35 cm to go beyond 50. It should be before 50. So at 35 cm, you have the pivot here. And let's see, marked by suspending a mass of 120 grams at the 10 cm. So if you take it from here, 10 cm should be here. So at the 10 cm, you have a mass of what? 120 grams. So can we just find the distance here? Do not forget, moment is always the product of force and the perpendicular distance from the line of action of that force. So in that case, we need to what? These are points. So let's get the distance. Distance there will be 25 if you deduct 10 from 35, and if you deduct 35 from 50, here should give 15. So if that is the case, I can take the moment. Taking moment at the fulcrum. So what do you have? You are taking moment at the fulcrum. That means this will swing anti-clockwise, while this swings clockwise. So in that case, and the principle of moment states that where sum of what the anti-clockwise moment is equal to the sum of the anti-clockwise moment. So let's see, the sum of clockwise moment here will be force, which is here where let's go ahead and still use the mass, because at the end, if you are using volume, it will still be converted back to mass. So let's say this value multiplied by what? 15 will be equals to, let's leave this also in grams so that we'll get our values in grams, then multiply by the distance, which is 25. So if you do this very well, m will give you 120 times 25 all divided by 15. And if you do that very well, your answer should give 20 grams. So if that is the case, 20 grams is D. Now number 12, which of the following action will reduce the frequency of an oscillation of a simple pendulum? So in this case, you need to know the relationship between frequency and the length of a spring. In that case, they are inversely related. So in that case, here we're talking about reduced frequency. If you are reducing frequency, that means you have to increase length. So I'll go by option B. And let's see, number 13. A force 15 Newton acts on a body of mass this for 5 seconds. Calculate the change in magnitude of the speed, which is the velocity. Here we'll go by the Newton's second law of motion, and that is F equal to what? M, change in speed over what? Time. So we are asked to calculate the change in speed, and that will be Ft over M. So what's the F? 15 times the time 5 over the mass, which is 3 kg. Please, if this is in grams, you have to convert to kilograms. So here you have 25. So if you check that very well, 25 will be your option C. Now let's see, number 14. The main function of a mouthpiece of a telephone is to convert sound energy into to electrical energy. Number 15. A body raised a load of 150 Newton through a vertical height of 120 meters in 30 seconds. So calculate the average power developed. Now let's see, what's the formula for calculating power? In this case, we'll go by work done over time. So if you check this very well, work done is force times distance over time. So tell me, what is the force? 150. So I have 150 times distance, 120. Mind you, is in meters. So if it's in centimeters, convert. Then you divide by the time, which is 30 seconds. And of course, it is correct in that unit. So this cancel, you have 4, and if you multiply this, you should get 600 watts, and that will be option D. Now number 16. In this question, we are given which of the following statements are correct. A pulley system is 80% efficient. It means that for every 100 joule put into it, the system, if it is sorry, if it is 80% efficient, that means if you are putting in 100 joules, then 80 joules of useful energy are obtained, while 20 joules of what energy are wasted. So as far as these 20 joules of useful energy are obtained is wrong. So this is correct, this is correct. So we'll go for statement 2 and 3. So let's do that. 2 and 3. So quick one. So let's see. So here 2 and 3, that will be option C. Then the next one, which of the following graphs correctly represent the motion of a body falling through a fluid? And the answer is A. Yes, so a body falling through a fluid will first of all experience an increase in its speed. So the acceleration will be increasing until the speed of this body becomes what? Uniform, that is constant. So first of all, it will experience increase, and it will get to a point whereby it will be constant. So this is it. Not this, not this, not this. Now let's check this. If you look at this, we see that it's telling you that it's uniform, then it decreases, and that's not correct. So let's go to number 18. A meter bar of length, 1 meter's cross-sectional area. Oh, in this question, whenever you are given, determine the magnitude of the force preventing the bar from contracting. We talk about expansion and contraction of what? Of metals. So of a metal bar, this formula is, we use the formula for force, which is linear expansivity multiplied by cross-sectional area, multiplied by the Young modulus, and multiplied by change in temperature. This can actually be derived from the formula of Young modulus equals to what? Tensile stress, which is force over what? Area, to be multiplied by the tensile strain, which is extension over what? Original length. But in this case, it's going to be length over extension. I believe you know why, because here I'm multiplying. So, and then let's see, extension here is the same thing as what? Change in length. You can now relate this to what? Linear expansivity, and you get this formula. So if you multiply, put in the values that you have here, and if you do that very well, your answer should give 10,000 Newton, and 10,000 is option 18. Yes, a glass bottle filled with water and kept in a freezer cracks on freezing because of the increase in volume of the bottle on freezing. No. Decrease in volume of the water. No, it is increase in volume of the water. Please do not be confused with this. There is absolutely no increase in the volume of the bottle, but there is an increase in the volume of the water on freezing, and that is what gives rise to cracking. Now number 20, in the vacuum flask, heat loss through radiation is minimized by the silver coating. That is correct. On the inner surface through, the answer is not diffraction. The answer is continuous reflection. Yes, continuous reflection of the radiant heat. Now let's go to number 21. A mass of gas at this question is actually under gas laws, and here you talk about the Charles law. In that case, you have your volume to be directly proportional to temperature. So in that case, for two cases, you have V1 over what? T1 equals to what? V2 over what? T2. So tell me what that will be. V1 here, you were told that it's doubled. So we want to assume V1 to be V. Let's assume the volume, initial volume is V, and the initial temperature is what? 0 degrees Celsius. But do not forget, in Charles' law, you do not leave your temperature in Celsius. It should be in the absolute Kelvin. That's the Kelvin unit. So Charles' law here. So if that is the case, you have to convert this to what? To Kelvin. That will be 0 plus 273, and that will give you 273 Kelvin. So if that is the case, you have 273 Kelvin here equal to V2. V2 is now doubled V1. So V1 is V, so you have 2V over what? T2, which is the final temperature. So if that is the case, V will cancel V here. Then you have 2 multiplies 273, and that should give you 546. If you do that very well, that will be T2 equals to 2 times 273, and that is 546 Kelvin. So thank you. So the next question is the unit of heat capacity is joule per Kelvin. And number 23, the rate of evaporation of a liquid is not affected by the answer is volume of the liquid. Yes, it's not affected. It's not, the volume of a liquid does not affect the rate of evaporation of that liquid. Now number 24, a measure of the maximum displacement of a vibrating object is the amplitude. Number 25, the speed of radio signal is this. If the frequency is this, calculate the wavelength. Now do not forget that wavelength is equals to speed over frequency. So what's the speed? Is 3 times 10 raised to the power 8, all divided by frequency, which is 10 raised to the power 6. So if you do this very well, you have 10 raised to the power 8 minus 6, and that gives you 3 times 10 raised to the power 2, and that is 300. Yes, that's B. Now let's see number 26. Number 26, a boy stands in front of a dressing mirror. A dressing mirror is what? You know what that means. So let's see, which of the following is he likely to observe? A dressing mirror is a plane mirror, isn't it? So in a plane mirror, you look at the properties of plane mirrors here. So let's see, for a plane mirror, the image size equal the actual side, which is correct. An inverted image, no. A plane mirror will always give you an upright image. The mirror is exactly at the midpoint, yes, that's correct, of the distance between himself and his image. A magnified image is from no. So a plane mirror will always give you what? An image of the same side. That means image side equals to what? The actual size. So that will be 1 and 3. So let's check. 1 and 3 is 26. That will be your option A. So yeah, we'll move on to number 27. So in number 27 here, a concave mirror can be used to produce a parallel beam of light if a light bulb is placed at the principal focus. That is when the image will be formed at infinity. So number 28, an object is placed 30 cm in front of a convex mirror. Please look at that word, convex mirror. A convex mirror will always give you, don't forget the concept, convex is likened to convert in terms of the image. That means this is visual, erect, visual here, and here is what? Diminished. So if that is the case, what then do you have? And of course, irrespective of the position of the object, so all these are just distractions. So all you do is that look at this, 2 times the size of the image, no, because it should be diminished. Inverted, no, it should be erect. Visual, yes, that is correct. 30 cm in front of the mirror. When it is in front, that means the image is real, and in this case it is visual. So we'll go for option C is correct. An object is placed 18 cm in front of a diverging lens. A diverging lens will have a negative focal length, and if that is the case, use the formula for use the lens formula, which is 1 over f equals to 1 over v plus what? 1 over u. So if that is the case, you have minus 1 over what? Focal length is 10 minus 10. So I want to calculate the image distance, which is v. So I'm taking this to this side. That will be minus 1 over u. U is what? 18. So that will be 1 over what? 18 equal to 1 over v. So if you do this very well, I can just go ahead and say 1 over v will be what? You find the LCM there. That will be what? 180. So 10 in 180 is 18 minus 18 in 180 is 10. That will give you what? Sorry, there should be minus here. As you can see, minus. That will give you minus 28 over 180. And of course, v will give you 180 over minus 28. And if you do that very well, your answer should be minus 6.4 centimeters. So now the minus there is telling you that the image is visual. Are you there? Yes. So thank you. Now, in comparing with the camera, accommodation of the eye is equivalent to, the answer is focusing. Which of the following arrangement of electromagnetic radiation is in order of increasing wavelength. So do not forget. And of course, microwave is somewhere here. So here you talk about decreasing what? Wavelength. This is decreasing wavelength. And if that is the case, if I'm going from here, so I'll be talking about what? Increasing wavelength. So if you check this very well, you will see that in this case, we are told increasing wavelength. That means you must move from gamma to what? To X-ray, yes, to ultraviolet, yes, to infrared. So option A is correct. If you check anyone here, you see that they are not correct. X-ray to ultraviolet to infrared back to gamma ray. No. Ultraviolet ray to infrared back to X-ray. No. Infrared to gamma ray back to no. That's not a good order. So you should follow consecutively. So let's see. 32. Sound from two different musical instruments playing the same note is distinguished by, of course, that is quality. And if you check quality very well, quality depends on what? Overtone. Yes, overtone. And that's in the same family as harmonics. So if you check here, you see that B is your answer. Now, number 33. The loudness of the sound emanating from a vibrating tuning fork, increasing the prong of the fork are brought close to the open end of a pipe containing water. This observation is due to, now you could see that here we're talking about increase in the loudness, and that is whenever you hear that in sound waves that has to do with pipes, yes, pipes, closed or open pipes, then you know you are in the realm of what? Resonance, because resonance is what will bring about increase in the loudness when you move them from within that pipe. So now let's see 34. Two identical spherical masses, each 2 kg, are attracted mutually. Here you have a concept here, which is the gravitational force, and that is Fm1 m2 over what? R squared. So this question is asking us to calculate the distance between them. So in calculating the distance between them, you have G m1 m2 over F. So tell me what that would be. G is what? G you are given to be 6.7 times 10 raised to the power minus 11. Please always make use of the constant given. Don't assume, don't say it's wrong. Once you are given, use it. So now let's say what's the mass? 2, then times 2, since they're identical and they have the same mass, and the force is what? 3.0 times 10 raised to the power minus 11. So this will cancel this, isn't it? Yes. So you can now go on and start what? If you do your calculation here, mind you, everything here is what? R squared. And if you punch this into your calculator, your R squared will be equals to 8.9, and which means you want to find the square root of what? 8.9. That will give you 2.9 or stuff. And if you check here, you see that the closest answer here is 3 meters. So we'll go for 3 meters here. So the function of a step-down transformer in an electrical circuit is to increase the voltage. No, please, step down. Step down means something high is being stepped down. So you don't talk about the increasing the voltage. No. So yeah, anything here that has to do with increasing voltage, they are wrong. So we'll go for this B and C. Decreasing the voltage, yes. Decreasing the voltage, yes. But what happens? Decrease the voltage and current, no. But decrease the voltage and increase the current in the secondary coil. That is correct for 35. So of course, if it is a step-up transformer, reverse will be the case of option C. So let's see 36. The ratio of pico and femto is equivalent to a pico. Pico is 10 raised to the power what? Minus 12. Then femto is 10 raised to the power minus 15. So here is going to be 10 raised to the power minus 12 plus 15. And that will give you what? 10 raised to the power 3. And 10 raised to the power 3 is what? Is kilo, isn't it? And that is option A. So let's see 37. In 37, you have the mass per coulomb. The mass per coulomb of a silver deposited at an electrode. Of course, if you check this question out very well, it is on electrolysis, and in electrolysis it has a popular formula of M equals to Z. This Z is called the electrochemical equivalent, and is the same thing as the mass per coulomb. So here you are given to be what? 1.118 times 10 raised to the power minus 6. Then the current is 1. Then the time is 30 minutes. So please be aware of this minutes. It should be in seconds. So it's going to be 30 times 60. So you put in all that, you will get your value to be 2.01, sorry, times 10 raised to the power what? Minus 3 kg. And yes, that was option A. So number 38, a current I passes through an element of resistance R in time t when connected across a PDV. The electrical energy converted in the element is given by, of course, electrical energy is power times time, and power is what? VIT. So if you check everything here, you see that option B is correct. Option B is correct. So let's go to number 39. In number 39, this question is on resistivity, and do not forget the formula for resistivity. It is RA over what? L. So here you have to calculate the length of the wire. So length will be equals to what? RA over what? Resistivity, which implies that L will be, what's the resistance? Is 2. What's the area? 66 centimeters squared. You have to convert that. Now, if you convert 66 centimeters, it's 10 raised to the power minus 2. And for the fact that it's squared, you now square the value. Then you now divide this by the what? By the resistivity, which is 0.0044. So here I can just say 4 times 10 raised to the power what? 1, 2, 3, 4. So that will be minus 4. So you see that this will cancel this. If you multiply this, you get minus 4. They will cancel out. 2 here is what? 30. Sorry, this is 22. 22 in 66 is 3. So here we'll go for 3, and that's 3 times 10 raised to the power 0 meters. So let's go to number 40. Which of the following action will reduce the sensitivity of a moving galvanometer? Here we have using a hairspring of I. No. If you make use of a spring of I spring constant, then the rate of deflection will be slow. So please, it shouldn't be high, but what? Low. So will reduce. So this will reduce the sensitivity of that galvanometer. Number 41, a bullet fired upward from a gun held 2 meters above the ground reaches its maximum height in 4 seconds. Calculate its initial speed. In this case, we have, of course, the body is being fired sorry, it's being fired up there. So if that is the case, we are making use of this formula, which is you know your formula now, x equals to what? Ut. But yeah, it's not going to be plus, it's going to be minus because it's vertically upwards. So to be minus half gt squared. So you are told to calculate this initial speed. So you have the height to be 2, of course it's in meters, so you are good to go. You then multiply by the time. What's the time? The time is 4 seconds. So this is 4 minus half times 10 times 4 squared. So if you do all this, do the needful, you will get your u. If you solve this and make u the subject of formula, that will give you 20.5 meters. Yeah, 20.5 meters. And if you check this, none of them is 20.5. So this is the closest. So we'll go with that. So now number 42. Or we put our answer there, 20.5 meters. Sorry, meter per second. Yes, it's correct. So number 42. A plastic sphere floats in water with 50% of its volume submerged. If it floats in glycerine with 40 centimeters of its volume submerged, the density of the glycerine is, take the density of water to be this. So in this case, whenever the body floats, that means upthrust is equals to the weight of that body. Are you there? So in this case, upthrust will be the density of the what? Liquid, then the volume of what? Of the object submerged, then you multiply by g. weight will be the mass of the what object to be multiplied by g. So g will cancel g, isn't it? So here is going to be what density of object, then volume of what object. So that is the volume of object, but this one is the volume of the object submerged. So let's say VOS. Why this is VO? So here what we need to do is, what is the density of the liquid? We need it, is unknown. Then what about the volume submerged? You were told that 40% of its volume was submerged in glycerin, so that will be what 40%. 40% will be 40 over what 100, then times, which is 40% of F. Let's say the volume is V naught, as you all know is V naught, so that will be what 40 over 100 V naught, then times, of course G has taken care of itself, so we have this, which will now be equals to what density. The density of this object in water is what is 1000, so you have 1000 here, then that 1000 will be multiplied by the volume of that object in water. Here we have 50% of its volume submerged in water, that will be 50% of V naught. So, and that's of course times g cancelled, so you have V naught cancelling V naught, and this will cancel this, yes, and this will cancel this, yes. So here you're going to be having, let me put that somewhere here, you're going to be having L naught equal to, you have 100 multiplied by 5, then divided by what 0.4, and if you do the needful here, you will get 1250 kilogram per meter cube, and that is option B. That will be option B. So now let's see, the next thing here is the terminal velocity of a body, of a ball bearing falling through a viscous fluid is reached when the upthrust is equal to the weight. Yes, this is very, very correct. So Zener diode is used for current amplification. That's correct. Counting of currency notes with a moist finger is based on the principle of course, that will be adhesion, because the currency has its molecules. The finger also has its own molecules. So here you talk about the force of attraction between molecules of what different substances, and that is where adhesion comes in. Now let's see 46. Now number 46. If a wheel 1.2 meters in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. So if you check this, you will see that this wheel is actually describing a circular motion, and the velocity will be equal to omega r. Now your omega r is your 2 pi f times r. Now your f is the 1 revolution per second. The 1 revolution per second, that means it makes 1 revolution in every 1 second, and that is frequency. So in this case, my v will be equal to 2 times 1 times, this is the diameter. To get the radius, what do? You divide by 2, and that gives 0.6, and if you multiply that, you will see that the answer to your number 46 will be, you can use this as 3.142, and that will give you 3.77 meters per second. And if you check here, you will see that is 3.8 if you approximate this. Now number next. Now in this question, you have the sketch graph shows the variation of an AC with time, determine the frequency of the circuit. Now here we have, this is 1 revolution going by how you count number of cycles in waves. So we have this 1 and this is 1.5. But in this case, if you check here, we're told that from here to here is what 4.25 times 10 to the power minus 3. So that means 1/4 is this value. So, and if I'm talking about one wave, 1 cycle will be from here to this point, and if you don't know the number of cycles, there is no way you can calculate the frequency. So now let's see, if 1/4 is 4.2, that means the period now, let's just say the period now will be what 4 times 4.25 times 10 to the power minus 3. Yes, so in this case, you want to multiply this, you will get 0.0 18. So this will be 18 times 10 to the power what? Minus 3. So in that case, what's frequency? Frequency is 1 over period, and that will be 1 over 18 times 10 to the power minus 3. And if you do that very well, your answer will give 58.8 hertz, and that is option C. So we go to option 20, go to question 48. In a good thermos flask, the main cause of heat loss is, the answer is conduction through the cork. Of course, there's no way you won't want to work, maybe have access to what is in the liquid. So you do this often, more than any of these other options given here. So let's see, number 48. When the base current of a common emitter transistor is kept at 0, it operates in the answer is saturation region. Please do not forget, if you've forgotten your transistor, don't forget that we have two types. You have the PNP and the NPN transistor, and talking about the emitter, talk about the base, talk about the common base and all of that. So this is very, very important for you to understand the keyword here. Now, because of time, let's see number 50. A 5 kg mass is moving in a uniform circular motion with a radius of 1 meters and a frequency of 3 hertz. Calculate the tangential velocity. It's still the same. The velocity is still the same formula here. So in this case, we have the radius to be 1. So here it's going to be 2 pi. Here the options are in terms of pi. So that is going to be, frequency is what, 3, and the radius is 1. If you multiply this, you will get 6 pi. That will be meters per second, and that is option D. And that is all concerning the question that you all did in your test. So I want to use this opportunity to wish you a very good holiday. Make sure you stay safe and keep reading. God bless you. Bye for now.